Okay, so for page 4 of your interactive notebook, you'll just simply put your page number. No title is necessary because it has a title here. We're finding the average rate of change, and we're going to do this from a graph, from a table, and from an equation. So if you'll lift this first tab to the left for me, please. Rate of change we talked about in class means that you are finding the slope. And so we know the formula we were given in Algebra 1 about rise over run. And we did this rate of change, we were finding them for linear functions. And because they were for linear functions, the slope between any 2 points was always going to be the exact same number. It was going to be constant. Now, we're going to be looking in this class at the rate of change of nonlinear functions. So what's going to happen if we have some curves in there instead? It no longer becomes constant, but it could definitely vary from one part of the graph to the other between any 2 pairs of points. You should remember that if you have a positive rate of change or a positive slope, that means your graph is going to go up from left to right, which means your y values are getting bigger as your x's get bigger. And if you have a negative rate of change, this means your y values are getting smaller as your x values are getting bigger because the graph is now going down from left to right. As I said, the formula that you should remember from your Algebra 1 days, it was talking about the slope, which is m, is equal to rise over run. Another way they said this was change in y over change in x, and they used the triangles to represent the words change in y over change in x. So what that really means is you're taking the 2 y values and you're subtracting them from each other, and you're dividing that by the subtracting of the 2 x values. Now, I'm changing the formula up just a little bit. You may or may not have seen this in your Algebra 1. Instead of saying y2 minus y1, I'm going to use function notation. I'm going to plug in a point, an x value. I'll call that x value b. And when I do that, I get a y value of f of b. I'm going to plug in a x value of a, and when I do that, I'm going to get a y value of f of a. So this means the second y value minus the first y value. It means the same thing, it just looks a little bit different. And then down at the bottom, instead of saying x2 minus x1, I'm saying b minus a. Those are the x values that I plugged into my function. Now remember, slope also measures how steep the graph is, so the larger the number in absolute value that your slope is, the steeper the graph is going to be. Please open up your second tab on the left-hand side. You'll have a graph that is an upside-down parabola. If we read the x-axis and the y-axis as to what's going on, the x-axis represents time in hours, and the y-axis represents the number of pairs of shoes being sold in the previous hour. So the directions say to calculate the rate of change from 0 to 3 and then 11 to 14. Once I do that, we're going to explain what each of these mean in relation to the graph. So what I did here is I went to x equals 0 and I went to x equals 3. Please remember, this is the interval notation form of x equals 0 to x equals 3. So I put a point at 0, 48, and I put a point at 3, 106. So if I were to represent a with the number 0, if I had an equation to plug that into, f of a would represent 48. B would be represented by the number 3, and f of b would be represented by 106. So for that segment of the graph, if I go to take and find the slope, I'm now on the right-hand side of your foldable. I'm using the space there to take these notes, but right beside the graph on the right. We're going to use that formula, m, which is slope, is equal to f of b minus f of a over b minus a. Again, that's your y2 minus y1 over x2 minus x1. When you divide those two values, you get about 19.3. Because this is a rate of change, you need to make sure and include your unit, so it's telling the story as to what's going on in this problem. So this is going to be 19.3 shoes sold per hour. So if I want to explain what that means in terms of the situation, I wrote that the store sales, because that's what it says, number of pairs of shoes. So the store's sales increased on average by about 19 shoes per hour from when it opened. When it opened means time is equal to 0, no time has passed. So that's why it says from when it opened to 3 hours later. There's a few key elements. The first thing is I said on average, because remember, this is no longer a straight line from here to here. This rate of change is actually changing from 1 hour to the other. So we can no longer say that that's exactly the rate of change, it's an average. So we have to make sure that if the graph is curved, we put this word average. I took the 19.3 and I rounded it down because obviously I can't sell 0.3 of a shoe. And it's per hour. That's the per 1 hour from the shoe sold per hour. And then you'll notice I also talked about what increment or hours that I did that over. I said from when it opened, that's time equals 0 to 3 hours later. If I don't include that, it could have been from, for example, 7 to 10 hours later. Could have been from 2 to 5 hours later. I don't know unless I tell what increment of time I'm talking about. I'll do the exact same thing for the interval 11 to 14. Again, I labeled my point and my f of b and f of a. I set up my formula for rise over run. I plugged this into my calculator. And then this time you'll notice I have a negative number as my average rate of change, and that number is negative 5.1 shoes sold per hour. So this time, because the 5.1 was negative, instead of saying the word increased, my sales are now going down or decreasing. So my Y values are going down from left to right. So I wrote basically the same type of setup. The store sales, instead of increase, we said decrease. Again, that word on average by 5 shoes per hour. Notice I don't have the negative in front there anymore, and I don't have the 0.1 because I can't sell 0.1 of a shoe. And it says from 11 hours after it opened, because that's what it says in my label over here, number of hours after it has opened, until 14 hours after it's opened. So you see an example of when you have a positive slope, and you see an example of when you have a negative slope, and how to compare the two with the situation that's been given. Please now open up the third tab down. We're now finding the average rate of change from a table. So on the left-hand side, you've been given this table, and it wants you to explain the meaning of the rate of change from 0 to 1.5. You'll notice that we have some weights and the length of a spring. So that means what's happening is they're adding increments of pounds onto a spring, and as it does that, the spring gets longer and longer, and I know that because the numbers are going up. So again, labeled the pieces that I needed. The 0 and 4 is a point on the graph, so I labeled that my A and F of A. 1.5 and 6.4 is also a point on the graph, and I labeled that my B and my F of B. Notice this 0 to 1.5 is talking about a set of numbers from x equals 0 to x equals 1.5, so it does not represent a point on this graph. So be careful in the way that things are being notated and what they represent. So for finding the rate of change, it's the same exact formula. We'll do our y2 minus y1, or f of b minus f of a over b minus a. We'll use our calculator, and we end up with a rate of change on average of 0.25 inches per pound. So I explained its meaning. I said the length of the spring increased on average by 0.25 inches for every pound of weight added between 0 and 1.5 pounds. That means as I add 0 pounds, half a pound, 1 pound, and 1.5 pounds, between these particular weights, that's going to give me on average a 0.625 inch length increase in my spring. Now I do want you to notice one last thing about this problem. I could actually take away the word on average, because if you notice, all of the x's are going up by the exact same increment, 0.5, 0.5, 0.5. And so are my y's, 0.8, 0.8, and 0.8. What that means is actually does follow a straight line. It is not curved, and because of that, I don't have to write the word on average. Okay? If you do, it's fine. It still means the same thing. And then if you'll open up the last tab, we have a population of rabbits, P of x, that are being modeled by the function P of x equals 20.5 parentheses, that's a multiplication sign with the 20, with the 1.014. This is raised to the x power, so I took out the caret key and the x and I put the exponential form here, the x as an exponent, where x represents the number of days since the population was first counted. And it says to calculate the rates of change from day 10 to day 20, and then again from 40 to 50, and then we just have to explain what each of them mean. So what I did is in my calculator, I plugged in x equals 10 into my p of x. This is what I plugged into my calculator using the caret key so that I could get this exponent of 10. And when I did that, I got 22.98 rabbits. I did the same thing for x equals 20, and when I did that, I got a population of rabbits, which is 26.41 rabbits. Now, clearly, I know that I can't have 22.98, and I can't have 26.41 rabbits, but I'm still going to use them temporarily to find my rate of change. So when I do that, I've got my formula, p of 20 minus p of 10 over 20 minus 10. I plugged this into my calculator and I got 0.34 rabbits per day. Now logically, I understand I can't have 0.34 rabbits per day, but for purposes of this part of my problem, I'm going to give the meaning using that decimal form. So it says the population of rabbits increased on average. I do have to say the word on average this time because if you were to graph this, this would no longer be a straight line. So the population of rabbits increased on average. The number is positive, so I know it had to have increased the population by 0.34 rabbits per day from day 10 to day 20. Again, I understand that I can't have 0.34 rabbits, but I also can't say 0 rabbits because that wouldn't make sense, and I can't say 1 rabbit either because that also wouldn't make sense in this particular situation because there just aren't enough rabbits yet for that number to become a whole number. So I have my rabbits per day as my units, but I also tell you from day 10 to day 20. It's very important that you tell me this interval of time from when to when, because otherwise it could have been, for example, from 40 to 50. So that interval of time is going to be very important when you're explaining what it means for the rates of change. Now I did the exact same thing in my calculator for 40 and 50, just simply plugged it into this p of x formula. I got these two values, p of 40 and p of 50. I plugged that into the average rate of change formula or the slope formula. I ended up with 0.52 rabbits per day. Again, I have another positive number, so I know my population is going to increase. But you'll notice it's increasing a little bit faster from day 40 to day 50. This is the importance of telling me from day 10 to day 20 versus day 40 to day 50 because they are not the same. And you'll notice that it's a little bit higher here. So now we've got about half of a rabbit being added to the population every day. So it says the population of rabbits increased on average, again it has to be on average because it's not a straight line, by 0.52 rabbits. Guys, I understand we can't have a half a rabbit, but for purposes of this problem we're going to use it to explain what's happening in the situation. So increased on average by 0.52 rabbits per day from day 40 to day 50. And that is the end of this page.